Hello and welcome to Studying with Chris, where I try my best to explain topics to help both you and me understand concepts. Today, we'll be going over absolute values and simplifying radicals. So, what are absolute values, you may ask? Absolute values, in short, are basically the magnitude of the value within the sign. So, what does this look like? These are your absolute value symbols. Say your value inside is -6. Your absolute value of -6 is equal to 6. This can also be represented on a number line, where the absolute value is the distance of the value from 0. So for instance, if we had a number line here, 0 and -6, the distance between -6 and 0 is 6 units. Similarly, if we had the absolute value of 6, this would still equal 6. So if we had a number line between 0 and 6, our absolute value would equal 6 units. Now, let's try some practice problems. Say we add the absolute value of 3 minus 8. First, we'd solve whatever is inside. 3 minus 8 is equal to -5. So we'd have the absolute value of -5. Now, if you haven't guessed already, -5 is 5 units from 0. So the absolute value of -5 is equal to 5. Now, what if we try this with multiple absolute values? So say we have the absolute value of 3 minus 14 added to the absolute value of 2 plus 5. Now, your absolute value signs almost act like your brackets. So you'd solve whatever is within the brackets first before you deal with the addition. So 3 minus 14, that would be the absolute value of -11, added to the absolute value of 2 plus 5, which is 7. So the absolute value of -11 plus 7 would be simplified to 11 plus 7, which is 18. So how does this connect to radicals? Before we dive deeper into that, let's look at what a radical is. Your radical will often follow this format. This entire expression here is known as a radical. Your value here is known as your index. Your value within the radical is known as your radicand. And sometimes there will be a value over here that is known as your exponent. Now, sometimes if you don't see an exponent, you'd assume your exponent is equal to 1. Now, oftentimes your radical can be written in a different way, where the index is a fraction of your exponent. So your radical can be converted to look like this. So this will be the general terminology that we use for this unit. Now, before we dive deeper into absolute values, let's look at some properties of radicals. So in radicals, you will encounter two main properties, one being the multiplication property of radicals and the division property of radicals. To put it simply, the multiplication property of radicals is just root a times root b is equal to the root of a and b. However, this is under the assumption that your index is all equal. Similarly, the division property of radicals is simply the root of a over the root of b is equal to the root of a over b. Once again, this is also assuming that your index are all equal. Now, with this in mind, let's take a look at a few examples. Say we have the square root of 2 times the square root of 5. Following this property, we can say that the square root of 2 multiplied by the square root of 5 is the square root of 10. Now, using the same numbers here, let's take a look at this equation. If we have the square root of 2 over the square root of 5, we can say this is equivalent to the square root of 2 over 5. So let's also quickly go over how to convert entire radicals to mixed radicals. So say we have root 18. This is an entire radical. If we're asked to simplify this, we can turn it into a mixed radical. So regarding our multiplication properties, we know that root 18 is equal to root 2 times 9. Now, we can also convert this into root 2 times root 9. Now, we know that root 9 is equal to 3 squared, so therefore root 9 can be simplified to 3, which means root 18 as a whole can be converted into 3 times root 2, or 3 root 2. Now let's take a look at the division radical property. So, say we have square root of 16 over 9. We know that square root of 16 over 9 is equivalent to square root of 16 over square root of 9. So, since both of these are perfect squares, we can convert this into 4 over 3. Now, let's look at one more example. Say we have 2 root 7. Say, hypothetically, if we want to turn this into an entire radical, how would we do it? So, since our index is 2, when we bring the value outside our coefficient into the radical, into the radicand, we'd have to use our index. So 2 times root 7 would be equal to the square root of 2 squared times 7. Now, we can simplify this further so that we have 4 times 7, which means our final answer, if we were converting it to an entire radical, would be square root of 28. So how does this all connect back to absolute values? Well, say we have square root of 9. This would just be 3. And we know this since 3 squared is equal to 9. So square root of 3 squared is equal to square root of 9. However, what if we have square root of negative 3 squared? Would the answer be negative 3? Well, technically yes, but in this case, no. Since in radicals, we take what is known as the principal square root. Now, the principal square root simply states that whenever you have two possible values, in this case it would either be 3 or negative 3, you take the positive value. So, in this case, if we had square root of 9 and we had the possibility to equal 3 or negative 3, we'd always choose the positive value. Now, let's look at if they were variables. So, if we had square root of x, whenever you're dealing with variables, the first thing you should do is define the variable. Now, in this case, x has to be greater than or equal to 0, since we can't have a negative square root, since that would be dealing with imaginaries. So in this case, we define our variable as x has to be greater than or equal to 0, such that x belongs to real. Now, since we know x belongs to real, the square root of x would simply just equal the square root of x, since x has to be positive. However, what if we had square root of x squared? Now, we know that if a negative number is squared, it becomes a positive number. So therefore, x has the possibility to be negative. So we can no longer define it as x has to be greater than or less or equal to 0. We can only define it as x belongs to real. Now, since x has the possibility to be negative, when we simplify our equation, we can no longer say that the square root of x squared is equal to x, since x has the possibility to be negative. However, if we're taking the principal square root, x can't be negative. So, if we're accounting for the fact that x could be negative, we have to assume that we'd be taking the principal square root. So, in this case, instead of saying the square root of x squared is equal to x, we say the square root of x squared is equal to the absolute value of x, so that our root would be positive. Now, in this case, you would have observed one thing. You have seen that whenever you have... Now, let's try a slightly different problem. Say we had square root of x to the 4. Now, before, we have to define our variable. So let's say x belongs to real. Now, we know that we can convert our radical expression to x equals 4 over 2. So we know this becomes x to the 2 when it comes out. So since this expression is equal to x over 2, would we need to absolute value this? The answer is no. Since we already defined this as being the x has the possibility of being negative, and we know whenever we take our expression out, we need to follow the principal square root. However, if x was negative, since there's this squared, it would be positive regardless, so we wouldn't need to worry about absolute valuing this. Now, let's try this problem with a different situation. Say we had x to the 6th, the 4th root. Now, before we do anything, let's define our variable. We know that if we have an even exponent, the value within the radicand will be positive. So we can only define our variable as x belongs to real. Now, let's write out our equation. So, this can be equal to x to the 4th times x squared, which, when we take out our x, we'll be left with x 4th root of x squared. Now, we defined our variable as being x belongs to real, which means x on the outside has the possibility to be negative. However, can we take out a root that is negative? No, since we need to keep the principal square root. So in this case, if x has the possibility to be negative outside of the radicand, we have to absolute value this x. Now what if we had x to the 3 to cube root? We could convert this straight to x. However, would we need to absolute value this? The answer is no, since if x was negative, it could still exist within a cube root. For instance, if we had cube root of negative 27, this can be only equal to cube root of negative 3 cubed, which means the only viable answer would be negative 3. Whenever you have a cube root of a number, you can only have one possible answer. However, if your index is even, you'll always have two possible answers, a positive or a negative value for your x. However, if you have an odd index, your value will only have one possible sign. that is all from me today. If you have any questions, please shoot me a message. Thank you for watching.